Hello everyone, my name is Jitendra Singh from Mysore University, AP, India. I am doing PhD under the supervision of Dr. Manikantan BM. Today I am going to explain our work. The title is Autoencoder Assisted Deep Spectral Learning for Hyperspectral Behavior Stain Classification. Next, I'll talk about what is hyperspectral imaging. So, hyperspectral imaging is a powerful technology combining spectroscopy with imaging capability. It enables gathering details information about the composition and characteristic of object and surface in a way that is impossible with conventional imaging system. In forensic research, hyperspectral imaging has become a potential non-contact technique across hundreds of continuous band in the visible and near infrared spectrum. It records comprehensive spectral information at every pixel. In contrast to conventional RGB system, hyperspectral imaging make it possible to identify small spectral changes that are not visible to our naked eye. Because of these features, it can identify chemically identical materials like dried beverage stain with great effectiveness. Next, I'll talk about few applications about hyperspectral imaging in terms of forensic science. So, first one is detection of blood stain and body fluids. Second one is latent fingerprints. Third one is document examination. Fourth one is beverage stain and age detection. Fifth one is gunshot residue analysis. So, among these application, we have choose beverage stain and age detection in this area for because in this area there is not much research, so we have choose this area. Next, I'll talk about how does hyperspectral imaging work. So hyperspectral imaging does not just measure each pixel in the image, but also measure the reflection, emission, and observation of electromagnetic radiation. It provides a unique spectral of each pixel, which can be used processing technique to identify and discriminate the materials. In below figure, you can see that top right below uh, that images, it shows the many bands compared to much more band compared to our conventional RGB image, that is only three channel, red, green, and blue. So we can say that we'll get much more information from this from hyperspectral image compared to RGB image. Right side, you can say that spectral signature we are getting from that hypercube, so it gives the more details about that materials. Next, I'll talk about hyperspectral image acquisition, how we will capture the image. So we have used the Specim IQ's hyperspectral camera for our research purpose. So the camera captures spectral information in between 400 nanometer to 1000 nanometer wavelengths, and minimum distance between the camera and the light source should be 15 centimeter, minimum 15 centimeter. It could be more than 15 centimeter, and between sample also the same distance we followed. The systems records a 3D cube with two spatial dimension and one spectral dimension. Each image contain 204 spectral bands, that is 204 channels, and the size would be 512 into 512 into 204 channels. So in below figures you can see this is our capturing process of two halogen light and one hyperspectral camera is there. And the light and the sample, that distance should be minimum 15 centimeter, and that angle is 45 degree. It should be 45 degree. And we have did this experiment in a room temperature that should be normal room temperature. It's not like like any specific area or something outside area. In our lab, we have maintained this that room temperature, and that humidity also we have mentioned, and that white reference is required for reflection purpose. So that white reference later will, for calibration purpose, we'll use that. Next, I'll talk about dataset preparation. So how we prepare our data set. So we captured hyperspectral image on of beverage stain on three different tissue paper, that is white, pink, and brown. And we have collected nine beverage stains. nine different kind of nine beverage tent, and the time duration we kept from starting 0 minute to till 5 hours. Means it's like 6 hours from starting 0 minute to 5 hours. And we have cropped, and after capturing the image, we have cropped the each spectral region, and we extract the spectral values from the stain and store in a CSV format. CSV form, and we created like this. We have created 9 different CSV file for each tissue paper. So if it is 3 tissue paper, and that is folded and normal tissue, like we have folded to also capture, and flat like normal tissue also we capture. So like this 54 CSV file we have created. From that we combine that CSV file in a single CSV file. So that data we have used for our training and like we for our experiment purpose we have used that data. And below figure you can see I have given one sample image of white tissue paper. So there is marked 9 different kind of beverage stain, and each part we have marked it like outside part we have not captured, we have not considered. Only the beverage wherever the beverage stain is there, that part only we have captured, we have just considered. And almost 1 ml, like in 0.5 to 1 ml we have poured the beverage on the tissue paper. Next I'll talk about different spectral signature of beverage stain. So yeah, here you can see here we can say that from starting first image, that is papaya beverage, the beverage name is papaya. So that spectral signature is different from that coffee. So that signature, the character is different from each beverage. So like this we have plotted out all 9 spectral signature of all the 9 beverage. And so this plot show the average spectral signature of different beverage stain, and each curve represent the reflectance value across the hyperspectral ambulance range. Although some beverage appear visually similar, but their patterns may differ, particularly around the range of 500 to 600 nanometer region. And this unique spectral characteristic provide discriminative features that enables accurate stain classification. Next, that I'll talk about the baseline model we have used for our implementation. To evaluate our approach, we implement 2 baseline deep learning model, that is MLP and 1D-CNN. So this baseline model helps us to understand how much importance is gained from the learning a compact spectral representation. So now I'll talk about proposed framework. So our proposed framework is it's combine unsupervised spectral representation learning with supervised classification. First, a fully connected autoencoder compress the high dimensional hyperspectral spectra into a compact latency representation. Then the learned features are passed to one-dimensional convolutional neural network to perform beverage stain classification. In this below figure, you can see this is the overall workflow of our beverage stain classification. Next, I'll talk about autoencoder and CNN learning. So the one autoencoder reduce the dimensionality of the spectral data by learning a compact latent representation. And in our experiment, the latent dimension was set to 64, which is we have selected because which preserve important spectral information while removing redundancy. The latent features are then received and fed to 1D CNN, which is used for final classification. So these are the comparative study of different models. So first one is the classification report of MLP model. And second one is the classification report of CNN model, and third one is the classification report of AE plus CNN model. So from this classification report, you can see that all the nine classes is there, and we have the classification report show that the proposed of AE autoencoder and CNN model improves precision, recall, and F1 score across most beverage classes compared to baseline model. This is the now I'll talk about model comparison of three model of different models. So from this comparison of classification accuracy, we can say that the bar chart compares the classification accuracy of three model, that is MLP, CNN, and autoencoder plus CNN. So the MLP model shows the lowest uh, performance among the evaluated method, and the CNN model improves accuracy by capturing spectral dependency. The proposed framework, that is AE plus CNN framework, achieves the highest accuracy, demonstrating the advantage of learning compact spectral representation before classification. And now we have plotted three models conversion matrix. So first one is the conversion matrix of MLP model. Second is the conversion matrix of our proposed model, that is AE plus CNN, and third one is the conversion matrix of a CNN model. So the conversion matrix for the proposed AE plus CNN framework shows the strong diagonal dominance, indicating high classification accuracy. And for most classification occurs between wine and pomegranate, and between whiskey and rum due to similar spectral signature. And now we are talk about the training and validation performance of across model. So here we can see the MLP shows the slower convergence and lower final accuracy, and CNN converts first but stop earlier due to early stopping. And AE plus CNN, that is our proposed framework, that achieve the highest validation accuracy and stable convergence. Training and validation loss decrease constantly because it indicate effective learning without severe overfitting. So now talk about our final conclusion and future work. So in this conclusion, we proposed an autoencoder based CNN framework for hospital variation classification. The framework effectively reduces spectral redundancy and improve class separately. Experimental result demonstrate that the method achieved almost 96.9% classification accuracy, make it suitable for non-destructive forensic analysis. In future work, we plan to integrate spectral spatial learning method to further improve classification performance. We also aim to test the system in a real forensic environment, including variant elimination, condition, and compound step. So these are my reference I have used for my work. Thank you.